So for the introduction, I'm going to deliver the introduction to you about environmental analysis. What is it about? So you can say lah, this subject is a continuation of a analytical chemistry subject that you may have taken in your diploma days or maybe earlier in your semester. Okay, now, first of all, now, when we're going to do environmental sampling, most likely we are going to monitor the level of pollution in the environment. Now, in this case, kan, there must be most likely you're going to chase after the guilty party, I would say. Why? Because the pollution usually comes from somebody who may have did the pollution and who may have polluted the environment, whether they realize it or not. So in this case, kan, there must be a guilty party where we're going to chase after. Now, in Malaysia, we also have legal system that we need to follow, just like what recently is all about. Now, last time you have water disruption the entire Selangor due to a pollution in the river in Rawang. Now, the person who allegedly, I use the word carefully, allegedly committed the crime were investigated, have their statement taken, and then investigation were carried out before they sent to the attorney's office for formal like charging. So they charged them in the courts. So there is a legal system that is required. And by saying legal system, everything that you're going to put in the legal system must be based on evidence. You see, evidence here doesn't sound too difficult, but actually it's quite difficult to use evidence and to prove that somebody is indeed guilty in committing that crime. Now, in order to do that, the burden, the burden of proving this guilt lies solely on the prosecution team, which is, of course, like you said, the Peguam Negara, and actually Peguam Negara is the face of the prosecution team. In fact, the real and the key people who is in the prosecution team is none other than the scientists themselves, the chemists who run all the analysis. And you guys, potentially, you're going to be the environmentalists. We're going to work with Department of Environment, going out, taking samples. You see, it begins with you guys going out and taking samples. Whether or not you're taking the accurate sample, whether or not you take enough sample, that starts from that. You see, the defense team, the defense lawyer might going to pick any one of the mistake, and there you go. You cannot prove they're guilty. You cannot prove they're guilty anymore, because the defense is much more easier than the prosecution. Prosecution have to prove all the evidence, have to be tip top, have to be correct and accurate. All the analysis and sampling, which is why you guys, in essence lah, I would say most probably you guys are going to be ended up as environmentalists or people who work in the environmental sector. So in this case, this will be your first skill set that you need to know how to take proper sample so that it is reliable and legally defensible. Because if you slack off a bit and the defense team lawyer can detect it, there you go, you already failed the entire case. You cannot prove that person guilty anymore until that person committed the same crime again. See, that's not easy to do that. Okay. So let's start off this lesson by saying that you need to take the sample reliably, and it can be defensively, it can be legally defensible. Okay. Now, scientifically reliable means a proper procedure for sampling and analysis are followed so that the results are accurate and it reflects the result as from the intended sample. Now, what does it mean by proper procedure? Now, this is a very vague word. Proper means what? You don't know that. Now, the procedure can be so many, because this procedure it can be for different medium. Now, when I say medium, that means water, air, or soil. Sometimes marine sediment as well. So these, based on different medium, they have different procedure. But I can say that most of these procedure also based on what kind of pollutants that you're dealing. Because when you say about pollutants, it could be organic pollutants, it could be inorganic pollutants, all of which are very different in terms of their chemical behavior. Some of them in natural environment, they're very soluble. Some of them may be very volatile. So these are the things that you have to take into account. Things that are volatile and very soluble usually are very difficult to handle, and you must have like a special procedure in collecting and preserving the sample. So it's all based on what you want to do in the sampling. Then you have to come up with a different procedure. And of course, the rule of the game, the rule of the sampling is, are you accurate? I'm stopping here very slow because why? Accurate means what? You hit the bullseye all the time, kan? This is what you learned in previously. Now, accurate means is how close are you to the actual result? You see, this is very subjective. Correct result. How do you know it's a correct result? You don't know, kan? But we have a way. And for those who already have like very good analytical chemistry skills, you will know accurate, you know whether your result is accurate or not by implementing QC procedure. Okay, I think I'll just stop here because why? 99% of the time, students, they don't know this QC procedure. So listen carefully. You want accurate result, you better know your QC procedure. End of the story. I will elaborate later what is that and why is that. Yeah. Okay, next point. The term defensible means the ability to withstand any reasonable challenge related to the veracity, integrity, or quality of the logical, technical, or scientific approach taken in a decision-making process. Now, you see, the decision-making process is not necessarily made by ourselves, the scientists and also the environmentalists who are involved in the sampling and analysis, but rather taken by the attorney general who decide to charge that person, or of course lah, in this decision in the court, that means the judge. Okay? The judge will going to decide whether the evidence presented is sound and it's reasonable to believe that the person has indeed committed a crime in polluting the environment. Now, in this case, kan, of course, lah, your data or the or the data that you have generated from your sample is perfect. So once again, the word perfect, what does perfect means? Okay. Now, if you don't know what perfect means, yeah, perfect data means is, perfect data means it is accurate, it is precise. And sometimes people also say that it is reproducible. You see, these are the three keywords appeared in analytical chemistry. I'm not sure if you realize it or not, but these are the three golden words lah. Not only three, I think there are several more, but these are the first three golden words that appear to define a good data. Good data is accurate, precise, and reproducible. These are usually the three keywords that define a good analytical or good data in science. So I think if you don't know what that means, once again, you catat, and then later on you relate back to how you're going to get these three. And once again, the answer to get these three criteria in your data, QC lah, of course, yeah, the quality control procedure. Okay, last point. Components of legally defensible data include, but are not limited to, custody or control, documentation, traceability. You see, once you have accuracy, precision, and reproducibility, these are the other three elements that you need to be mindful when you're going to need your data and you're going to use your data in the legal system. Because for those who have watched CSI before, I know CSI is not your thing. It is a thing during my time 10 years ago, but nowadays you cannot see any CSI movie series. But during that time, it is a very hot topic. In that movie, there are a lot of like episode that shows the what the mismanagement of sample in terms of custody. See, um, so the custody was not maintained during the process of transferring the sample to the lab. There goes the data. The entire defense is lost because of this loss of custody. I think maybe after this we're going to explain, but if I don't explain the custody of control, then I'll come back to you and explain that. What is that? Okay, next point is documentation. Documentation means whatever that you have, including the sampling plan. Sampling plan is the first documentation, yeah? The planning. The next part is after you have your sampling plan and you're doing it, you have to document every single information, beginning with the location, the time, whatever the sampling the scientific data related to sampling at site, the temperature, moisture, all information as required. Now that also includes the person, first the identity. Who are the person who did all the sampling and who are the manager of the site? But you have site manager as well. So all the information have to be cited there. And when you want to transfer your sample to the lab, analytical lab, inside the analytical lab, they also have a lab manager to receive your sample. So you can see that there are documentation here, beginning with the identity, the methods that you're going to use, and of course, the data. Data and reporting also is part of the documentation. So everything has to come with usually what people say black and white. Black and white means something that is clearly documented and written down. Last time it's written down, but nowadays you can actually type written it. Same thing. We call it documentation. Yeah. Because why? With documentation, then only you have traceability. From the documented files that you have, then it is traceable. Because why? Whenever the result is presented in the court in front of the judge, there will be just conclusion, maybe a certain details of data. You see, sometimes the defense lawyer, they might want to pick up something. They were going to give you all the world of trouble. I mean, this is how defense lawyer would lah. They're going to give you all the trouble and they ask for documentation from you. They want to trace every single steps that you do in analyzing and sampling the environmental medium. And they just need one of your mistakes. If they can trace one of your mistake, then you lost your case. But in this case, guys, traceability is one of the rules of the game. You have to get ready to be traced. People, if you really do, if you end up as a chemist and you really go to the court and charge a person, you might be called into the court and make statement. So you're going to cross-examine by the lawyer, or lawyer ask you, what do you do when you sample the soil? What do you do when you sample water? What do you do? Everything. So this is part of the things. They want to recall what you did. So it is easy lah if you have documentation. Now the traceability is that lah, yeah. Okay, now I was right. Now custody. So I'm going to explain like in detail what is custody. Now in this case then, custody is important to maintain the integrity of the sample. Integrity means the sample is what it is and represent what was collected at the site. For example, if you go to a contaminated site that belongs to a person and allegedly contaminated by the owner of the land, you go and sample it. And then from the sampling onwards until the transfer to the analytical lab, you will need to write down your name. Like for example, once you collected the soil sample, you put it inside a plastic bag. You will need to seal it. Then in front of this bag, you have like a borang, a note, and you're going to fill in your names. Fill in your name, your IC number, and your contact number. If you don't do the transfer work, you may need to pass it to the second person who is going to transport it to the lab. So during the transfer, change of hands, I call it, change from your hands to the courier. The person who is in charge, who starts to transfer this sample to the lab, will also need to do the same process again. Write down their name, write down their IC number, and also their phone number. And after that, there they go. Passed it and transfer. So you can see like the custody card, there is like a chain of custody. And to secure that is the only way that you can properly ensure like the integrity of a sample. You know who are the person who is collecting, transferring, and analyzing all the sample throughout the entire process. So when people want to check who are this person, they know. Because why do we want to know this person? Now, this person who is assigned on sampling, transferring, and analyzing must be authorized. Authorized means given the power to do so. Because why? Because there are a lot of tricks people do in order to fail this case. Like for example, when you want to take sample, they might assign somebody they know, and then they assign somebody they know, and they bring siap the uncontaminated water and say, "Oh, this is taken from the site." Then no case like that because it's not contaminated. It does not represent the sample. Right? So that's why chain of custody or custody of control is so important to maintain the integrity. You get the sample that you wanted, you analyze it the way that it should, and then the result will reflect what actually happens at the site, whether there is a contamination or not. Okay? So I know I did not read the slides because I'm interpreting based on what is stated right here. Now, to put things simple, custody or control relies on chain of custody, or in short form, we call it COC. Chain of custody is no different than filling up forms. Every time you transfer hands, you fill up that form. And that is a must. Whenever you do any sampling, that is a must. If you don't have that, then you're not qualified lah as a environment technician. Environment technician must know all these things. Yeah. So okay. So the point is, why do we want to have this custody control? We want to maintain sample integrity, and we want to prevent tampering. Tampering means uh, you do something lah with the intent of skew the accuracy of the results. Okay, done with custody of, or control. Now, documentation, what is it? Documentation is something used to certify, prove, substantiate, or support something else. So, in other words, black and white, you can call it. It can be written, it can be a report, it can be a statement. Now, even COC, chain of custody form, is part of the documentation. So here it is, chain of custody form. Yeah. Or it could be photos as well. So that's why whenever you go to the sampling site, usually it's not just a form that you need to take. For myself, my note taking is my smartphone. I take as many pictures as I want, and in my picture, I timestamp it. Every time I take picture, I know when did I take it, and some of the good smartphone actually can actually timestamp, and they can also stamp the location. That's even better because every time you take the picture, you also know the location. It makes your reporting much more easier. So it's not just black and white. Sometimes photo taking also it's also part of the process. Notes, reports, computer printout. So these are the so-called documentation required lah. Now, because why? Most of this documentation will need to be referred if needed. And most of the time, the reference might be made by defense lawyer or the judge. Or the prosecution lawyer will need to prepare this document properly. Like that. Okay, for those who are not so familiar with legal system, it start off with the prosecution lawyer. They prepare all this documentation. Well, of course, not the lawyer don't go into the lab. That is for sure. So where do they get this documentation? From you guys, of course. People who do the sampling have their own COC. Once the sample reaches the lab, then the chemists will going to take over and analyze the sample. So what do they have? They also have their internal reports. They also have several reports for information, like preliminary reports that only have data and no discussion, no interpretation, maybe with slight interpretation. But once they go period. Now, inside the analytical lab, they have a lab manager. The lab manager is usually those person who can certify That means whatever the result that they are seeing, they will check, see whether they're accurate or not, they're precise or not, and then they will go sign off. Only those documents that is signed off by the lab manager, the authorized lab manager, have power and have weightage to be used as part of the documentation, the documents for prosecution. You see, not every Tom, Dick, and Harry can use the report, like your lab report. Like, for example, let's say if you go to a contaminated site, you take the sample and you analyze it, and you sign your own name. Useless. Your name is useless in the court. Because why? You're not authorized. You're only student, kan? You don't have the skill set to do it. So that's why I say these are the documents, the proper documents that we use in the court later on. Okay. So it is compulsory for students of this course to use laboratory notebook for the entire duration of study. Okay, now unfortunately, this last point is not applicable because what we no longer have field trips. So no field trips, no lab notebook. But if you're in EBT 533, soil science subject, yeah, this is a must now, yeah. Okay, traceability is where you need to trace back what happened in the entire process. So what is received by the judge is the result. Then people might question, is this result accurate? Yeah, the defense lawyer and the judge have the right to question. They should question because after all, this is a court that may decide the fines, maybe up to thousands. Currently, the Minister of Environment voted out to increase the fines to millions. So you see, we are talking about millions. Some people might lose their life because of the court cases, of course. I haven't heard anybody who is hanged due to offense in contaminating the environment. Usually is people. But you know the point. The stake is very high. See? So traceability stems from the rights of the court to question. They were going to question every single data that you present to them. And of course, they're going to trace it. Who did this? Who come up with this data? Of course, they're going to find who are the lab managers who authorize and sign off this data. Yes. They can actually trace until the source of this sample, which is you. If you collect a sample, you sign off the chain of custody form. So they might trace all the way until who collected the sample. Because why? There might be some questions that may ask who collect the samples. Does that person actually have conflict of interest, or is that person, put it simple, a relative of the person who is being charged here, or a friend, or people that they have contact with? Because in order to establish the integrity, that's why this is what people do. We want to make sure that the data that is presented in the court has a high integrity and can be trusted. Okay, so traceability is particularly important with regard to the standard that are used to calibrate the analytical instruments. So these are also part of the aspects that they want to see. Not only they want to see the integrity, they also want to see whether the data or the sample has been analyzed as it should be. See, we never know, guys. We only see the data. How people do it, they want to know all the standards, whether or not the analysis was conducted using the standard method. See, there are many methods that you want to determine pH cut. You can use litmus paper. You can use universal indicator. You can also use a pH meter electronically. But which one is acceptable in court to charge a person? Of course, it's going to be electronically and also cross-check with titration. So do you see what I'm talking here? There are methods, acceptable by court. Not all the methods are acceptable. So you also have to follow a certain regulation, okay, in order to be acceptable, okay, the data. And of course, we are looking for what? Accuracy. The reason why only a certain method is acceptable is because those method usually is certified accurate. They produce an accurate result as required by standard. That's why it's a matter of life and death, it's a matter of millions that you're going to pay fines of. So the data have to be very accurate. And how to get accurate results? It must come from the correct methods and standard. These are the things that the defense lawyer were going to try their best to find out. Of course, lah, they were hoping that you guys not learning EVT 536 enough and commit a mistake. Then they'll be very happy because they find a loophole and they can dismiss your case just like that because you use the wrong method. They will trace you. That is what they do. Yeah. So make sure you know your methods lah. Use a standard method, and traceability is also one important. Okay. Now, I think I do not want to dwell too much on this one lah, because what? You learn in secondary school, you learn in diploma, and you learn it again right now. Right now, for those who already taken analytical chemistry lah. So this one, I leave it to you. But this will be a very key and important elements in environmental sampling. Because to determine systematic error, it depends on what method that you use. Like I said earlier just now, what instrument that you have chosen and why. Because if you choose the wrong instrument, your result will carry systematic error or maybe random error. And then your result will suffer in accuracy and precision. See, now I want to set your knowledge straight, lah, yeah. There is no one method that has no systematic error and no random error. Every method will have both errors. The only difference is some method have very little systematic error or random error or n random error. See, these two errors will exist. The question is how big? Of course, nah. In order to have the best data to be presented in front of a judge, you need to select a method or choose an instrument that have as little as possible systematic and random error. Enough said. You will need to read yourself lah, because you should have. So I'm going to introduce to you lah, how to ensure that you have the best quality of data in terms of systematic or in terms of accuracy and precision. These are the things that usually is implemented in any analytical labs. I can say like 99%, if you're not into like entrepreneurship, if you're not doing your own boss, your own business, you're going to work in an analytical lab, going out about collecting your sample. So all those labs were going to have its own in-house QA policy or QA programs. Well, QC program. You can read yourself what is QA and QC and the difference it means. And once again, QC, okay, by the way, it begins with QA actually. It starts with QA, not QC. It starts with QA where QA program is actually steps or policies or management system to ensure that the QC program is working well and give you the accurate and precise results in the analysis. So it's actually more of a management. Quality assurance or QA is more of a system or policy management to manage the quality of the analysis of your sample. Whereas QC is the technical side, is more technical, in which in QC, in quality control programs, it will outline every single steps, procedures, just like your lab manual. Okay, just like your lab manual. Every single procedures that you need to do, and they are going to have like a discussion on how to measure accuracy, precision, as well as uh, steps on how to prevent the inaccuracy or the low precision of your data. So these are the so-called the techniques. So you can say QC is actually what you've learned previously in analytical chemistry. I give you an example. In this QC program, it may start from how big is your sample size? As simple as that. How many samples do you need to collect in order to have a very accurate result and precise result? That also is part of QC, number of samples. Okay. Apart from that, you might need to get involved also on how to prepare your sampling trip. Now, sampling trip also you need to prepare because there are so many aspects. Like, for example, what container should you use? What container should you use? And how should you use a container? All the technical things, step by step, is in the QC program. And not to mention also the last one, which is probably one of the most the most important part is how do you preserve your sample? Okay, don't worry, because why? We have soil, air, and water. Every single medium, their preservation and collection, they are very different. So which is why in this first lesson, I'm just giving you the simple things only. So these are the environmental data acquisition process. It starts with the sampling, then the sampling technique, sample preparation, analysis, and data analysis. It's very much what you do currently, except that this is more systematic and it follows a certain methods and rules. So there are a lot of methods, but QA and QC encompass every single part of it. So you probably don't realize that even in your lab report, you should also mention the QC. Of course, you don't need to mention QA part, it's policy. But QC in your lab report, you should mention it. And I believe I've told you so. For those who have also registered EBD 533, I've already mentioned to you error analysis. Remember, error analysis is part of the QC. I think enough is said, lah. Yeah, you should be able to realize it. Okay, last two slides. Before I end this lesson, I just want to show you, what are the pollutants that you are going to deal with whenever you do sampling. Not only is because for your safety, but also to better handle and manage your sample during the sampling process and analysis. So number one, the pollutants may be of metals. Now, metals or metalloids, they carry different behavior. Some metal may appear as gas. So if you don't know which element is a gas here, is mercury, Hg, right here. The rest of it either is a solid or liquid, they dissolve lah. Metalloids, they may behave differently than those metals on the left here. So I'll let you discover. Number two, inorganic compound. It could be cyanide, carbon monoxide. What are these? These are gas. Cyanide may be dissolved in liquid. Asbestos, they are suspended particle. How do you deal with it? You ask the virus on how to do it because it's part of the air pollution. Yeah. Okay, number three, organometallics and metalloid compound. Now, these are essentially metal compounds, but they are attached with organic component. Why they are here? I think this one missed out one very famous organopollutant, which is diethyl mercury. Yeah, you have tetraethyl lead, tributyltin, but one very famous one, diethyl mercury. If you don't believe me, you can search what is diethyl mercury and how one doctor died from it, documenting every single thing, died horribly. Of course, that is like synthetic material is not available outside, but you should know in case you're dealing with this thing. Okay, number four, hydrocarbon. Okay, I think this is very easy. Like a hydrocarbon is, you say, carbon and hydrogen. This is what it could be: BTEX, benzene, toluene, enzyme, xylene, and it could be PAH. These are all from oils. Example, very easy 2 weeks ago, why Selangor does not have water? Because of this because that person allegedly reprocess the used engine oil. They filter the engine oil and resell it. And what happened to those waste? They just throw it into the river. So we get all these things last time. These are the things that end up in the water treatment plant and why they're so difficult to clean. Maybe next time I'll explain to you. Yeah. Okay, number five, oxygenated compounds. These are alcohol, aldehyde, ether, organic acid, ethyl, ketones, and phenols. Well, it sounded like it's like very ordinary chemicals, but each of them may have different hazards, I would say. Yeah, some very dangerous, some may not be, but these are the examples. Okay, number six, nitrogen compounds. It could be amine, nitrogen, and so on. These are usually toxic materials available in pesticide. So does the halogenated hydrocarbon. These are also toxic in a way either is released as a pesticide or as a byproduct of combustion. And number 8, organosulfur compounds. These are from, not pesticide, these are fungicide. Okay, these are the compounds or chemicals to kill fungus. Yeah, and number 9, phosphorus compound. You can say pesticide, but more famous lah. These are the nerve agent. See the operatives lah, the operatives from other countries who intended to kill. You see, last time there's one operative who come to Malaysia and kill one guy from North Korea. He uses this one, phosphorus compound. Very good in killing things. And then other loosely defined chemical pollutants can be heavy metals. So heavy metals is reserved for any elements that are very heavy in terms of atomic weight, but it is not different than metals itself. Some of them may define as metalloids. VOC, volatile organic compound, any compounds that are volatile. So it could be organic compounds, it could be anything as long as they appear as gas at room temperature. Because Malaysia is very warm, so most of the compounds, especially organic ones, they are volatilized or semi-volatile. Now, if they're semi-volatile, they are still organic compounds. But why they are semi-volatile? Because they are heavier. Either they're heavier or they have stronger interactions, so that's why they're not too volatile. But either way, probably they can kill you based on what are the compounds, what are the chemicals that are involved and contained in this media. So, the end. I have a question. Can a person good in environmental practitioner without having a good fundamental knowledge in inorganic or organic chemistry or analytical chemistry? What is the answer? Yeah, probably you don't know. But my answer would be, if you want to be a very good environmentalist, not only it is not about doing demonstration outside like most of the environmentalists do, but rather be good in your fundamentals, the chemistry first of all. See, if you want to be a good environmentalist, you have to be first a good chemist. If you're not very good chemist, okay lah, half good also can. But you cannot be somebody who don't know chemistry. So what does that mean? If previously you failed chemistry or you're not doing too well in chemistry, get ready lah, yeah, because this subject is all about chemistry, statistics, but mostly chemistry, like I have to say. So with that, I end this lesson, and we have about 5 minutes for Q&A session. So I'm going to switch over. Right, I have one hand raised from Shazwani. Any question? You put your hand down again, Shazwani. Okay, never mind. You can put your hands down, but you have to be sure what I've talked about just now. So now is the discussion. If you don't understand what I talk about, okay, now is your time. You can ask me whatever you want to ask regarding the lesson, first lesson. Because if you don't have anything to ask, I don't want to waste time and I want to show you other things. Okay. If you can, and you're in front of a laptop, I want you to go to FSG homepage. I know you probably don't see too much of information right here, but there's one information that I wanted you to see, which is under research and research facility. Labs maybe not so first lah, because labs it can be anything. I want you to go to research facility and have a look at all the instruments that we have. You see, at this point, I know some of you may not have taken subjects such as instrumentation. Last time students take it before this subject, but what to do, you learn it earlier. Now, there are a lot of things that you will probably use in analyzing the samples that you collected. Like, for example, the air samples that you collected. What are the instruments that you're going to use? This one, gas chromatography, or maybe gas chromatography with mass spectrometer. It's quite safe to say these are the two major equipments. Major equipments not just for analyzing gas samples, but environmental monitoring as a whole. These are the two major ones now. So when we browse further, you also can see HPLC, HPLC first, and ion chromatography system. So ion chromatography system and HPLC, what are they for? they are used to separate any contaminants that they have, and then they analyze it separately. HPLC and ion chromatography, although both are based on the principles of chromatography, but they analyze very different pollutants. HPLC mostly is for organic pollutants, whereas ion chromatography, the inorganic pollutant like ions, like cations or maybe anions, these are what they do. Okay. And then maybe ICP OES, these are the ones who analyze heavy metals or metalloids, and they are very accurate. Yeah. So a lot of instruments that we have right here that I do not have the chance to show you everything. So might as well you come in here and see which one is applicable, because you know why? You know why? You remember just now, assignment number one? Ah, when you do assignment number one, you need to consider every single of these things. These are the instrument that is available to you. You need to cite. If you want to do analysis, you have to make sure that the instrument is in FSG. That is a rule. You must. So you can take your information from this website, yeah?